Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. This reaction is an acid-catalyzed dehydration of a secondary benzylic alcohol, 1-phenyl-1-butanol. Actually PHCH of CH to CH3, which is 1-phenylbutane-2-ol. Reading structure PHCH of CH to CH3 is equal to 1-phenyl-1-propanol with ethyl. Let me reread. The structure is PHCH of CH to CH3, i.e. pH attached to CH, or then CH2, then CH3. This is 1-phenylbutane-2-ol. Under H+, acid, this secondary benzylic alcohol undergoes E1 elimination to give PHCH is equal to CH-CH3, 1-phenyl-1-propene, both E and Z isomers. Moving on to the next step. Loss of water, O and H, from the alcohol under acidic conditions is equal to dehydration reaction. Statement A is true. Moving on to the next step. The alcohol is secondary and benzylic, so under acidic conditions it forms a stable carbocation, secondary benzylic carbocation, and then loses a proton. This is E1 mechanism. Statement B is true. And for the final step, E1 reactions do not require a specific antiperiplanar arrangement, unlike E2. In E1 the carbocation intermediate can lose a proton from either phase, giving both E and Z products. However, the reaction does show some stereoselectivity because the E-trans isomer is more stable, less steric strain between the phenyl group and the methyl group. The E isomer is typically the major product due to thermodynamic stability. Statement C says the reaction is stereoselective. This is true because a preference for one stereoisomer, E, over the other exists. Statement D claims the major product is the Z-alkene. In the E1 elimination giving PHCH is equal to CH-CH3, the E isomer, trans, where pH and CH3 are on opposite sides, is more stable due to reduced steric interaction. Therefore, the E isomer is the major product, not the Z isomer. The Z isomer would place the larger groups, pH and CH3, on the same side, causing steric strain. Thus statement D is not true. Why other options fail, A, B, and C, are all correct statements about the reaction, leaving D as the false statement. Therefore, the correct answer is D. Therefore, the correct answer is option D.